Yeah, perfect. I was told there was a video, so I was waiting for that. So first of all, who of you identify as front-end developer or front-end engineers in the crowd? Further up, I can't count it. So about half, that's good. This talk is for you. How many identify as backend developer or platform engineers? It's also kind of for you, so that works out great. But it's called DevOps for front-end engineers. So I myself like to think of myself as a developer first and foremost. I've been doing programming for a while, and I like to think I'm fairly proficient all the parts of the stack. But if I'm being honest with myself, I think I have some sort of inferiority complex for backend and platform engineers and folks. And traditionally, ever since I started with like HTML, CSS, JavaScript things like 20 years ago, always heard that HTML, CSS isn't a proper programming language because it's markup, and markup is something else than actual programming language. So that's something I've heard for my entire career, I think. So imagine my surprise now in 2025 that the real same hardened backend developers is also the same that's surrounded by YAML and markup files every day. So now suddenly, apparently, that's proper programming, unless markup wasn't just a few years ago. And I think that's because it's DevOps, and DevOps is cool, DevOps is great. So for some odd reason, DevOps, I think, is something that's mostly talked about from backend and platform engineers. So I think it's the most hardened backend developers that does metrics, talk about infrastructure as code, CI, CD pipelines. But of course, that's not the entire picture of DevOps, and I think we'll dive into that. So let's see how what it really is. So DevOps is much more, in my mind, a tool for avoiding a bad production. So it's much more than just tooling and infrastructure. It's avoiding people standing there, being left in the rain and having to act and so forth. And I guess every one of you have the same story. For me, it's like doing solutions and applications that's critical for people I know, my family that uses things I've also contributed to. It really, really embarrassed me when someone actually calls me and says my thing that I've helped created doesn't actually work. And I have no idea. It might work, but for some reason, some external party notifies me that something doesn't work. And that's a rough one. And so DevOps is a measure to avoid those types of embarrassing calls and having to explain to my family what I actually do. So it's much more about avoiding the rain and creating sunshine in our production environment. So as front-end engineers, we often do like critical things. We solve critical user flows. We solve something with high impact, both for the users themselves and for the organizations within. So we cannot only be meteorologists, but we need to be actual freaking skybenders to control the environment itself as well. Because front-end is complex, and it's production critical, it's user-facing, and DevOps is all about taking ownership of that production critical thinking. So I think DevOps is very much relevant for front-end engineers, but it's under-communicated and under-talked about within that segment of the developer community. So I like to think of DevOps as consisting of 3 parts. Some of you might argue that this is actually 5 parts, and I've cheated, but deal with it. So I think it's operational and productional responsibility is part philosophy and culture, and part methodology. So today we'll look into all these aspects and facets of DevOps and see how it pertains to the front-end engineers themselves. So it's much more than just one single developer handling a bunch of YAML files, but it's more a team coming together and improve the way they work. So DevOps is a team effort, and making sunshine requires ownership from the entire team. So production and operational responsibility, because the job is not done when committing code. It's done when we see the effect and wanted effect from the end user or the organization or the system we're working within. So, and it's a continuous work. It doesn't mean, just because it worked today, it doesn't mean it will work tomorrow or even the next second. So to maintain Sunshine, we need to understand it's something is within our control to fix, and it's within our control to have it working, and we have to take that responsibility. So not someone else, a third party, but it's our responsibility, or it's your responsibility. Luckily, though, it's the plural type of you, so it's you as a team, not you as a single person. So making that a team effort, I think it requires some cultural improvements for your team and the organization itself. If you want to ensure the Sunshine, we need to come together. So I think it's really important that it has to infuse like the cultural DNA of your team, because when things go wrong, you will act a certain way or react a certain way, and the more high pressure the situation, the harder it is to react. So having the part of the cultural DNA to act some certain way will help us do the right call when shit hits the fan. So when things go wrong, I think we will waver, but having it a part of the DNA and the culture itself, it's much easier to make the right calls. Because issues will happen and things will break. So philosophically, I'd say that DevOps on a higher plan is about flow, and we'll dive into that later on, I think. And I'll also say that it's methodology or process, because if we are to succeed in building a culture and taking responsibility, we have to grain it in some sort of like mechanisms to work. So I said that philosophically it's more like flow, and it's flow from a requirement over to realization. And if we want to build a good flow of that, we have to have some sort of structure to make that work. So I think that alignment in the way we work, in the way we act as a team, as a culture, as an organization, that requires some sort of system or some sort of method and process to work. So that's a tool for DevOps itself. So if we want to ensure like the everlasting sunshine in the production environment, we need to ensure that if there are any problems, or when there are problems, because there will be, we have to make sure that we detect them, that it's possible to detect. We need to see what the actual problem is. That's not given. And we want to see what it is as quickly as possible, because the time it takes for us to realize it and to fix it, that's a critical part as well. Hopefully, also we are able to improve it as quickly as possible, and to fix whatever is the issue, even if it's a misunderstood requirement or is an actual bug out in the production. And we have to be able to patch that fix as quickly as possible as well. So we need to detect it, find it, understand it, and fix it. And hopefully, additionally, maybe we could prevent that from happening ever again. So this is something we developers like to think of as flow-based development. So where we roll out changes and we observe the effects, so that's back again as a part of a feedback loop of verifications and quality assurance. So often we want to minimize the time from some requirement occurs over to that we can observe the fix of that requirement in the production environment and hopefully learn from that as well. And the reason we want to minimize this is because as faster, again, the quickly we can discover things and fix things, that causes less errors in production, so it maintains the sunshine. A sub-part of that in DevOps is called the cycle time. So it's essentially the time from you start coding or start your first commit and able to observe that commit in production. And to reduce that time, just as a natural consequence of what we're discussing, to be able to fix things in production as quickly as possible, and you have to reduce the time it takes from you starting the code to it can be observed in the production environment. So there are a lot of consequences of that. We can improve that time and drastically improve our ability to make sure the production environment is in a happy state. So we can improve the time it takes to actually do the building part itself. We can make it easier to debug. We can reduce the scope of each task to minimize. So that means small changes. We can make sure we never have to do deploys at all. That's a way to reduce the time. And we can ensure that anything doesn't block us from doing a change, because that's often the case, that we are able to do some sort of fix and we know the fix, but we're blocked because of other changes that can collide with our intention change. So let's take the first part here. So improving the actual continuous integration, continuous development phase of it. I won't dive too much into this, but I think it's important for front-end engineers to also take a part of this. This is not like a platform engineering stuff. There's a lot of things to fetch on this, because you can leverage caching. You can have actively thinking of what kind of steps can you make in parallel. And is there any steps that's not critical for actual doing the integration part? So a lot of things that front-end engineers has to do and cannot outsource to anyone else. I have a story on this. At some point, we had an issue with an app, and it took 5 hours to build the app before someone on the team, namely Christian here, said this is too long, because when we discovered something at all, it took literally 5 hours before we can verify it in staging if it actually worked or not. And 5 hours is a long time to verify, and you say that, okay, it worked locally, but it didn't work in staging, so it take probably 10 hours, and all it took was to actually try to think of the most cases we're doing deploys is just that part of the system, so we can change the way the CI works. And he reduced the running time, I think, from hours to minutes. And that's improved the flow, not in all cases, but most cases. That's the type of thing that we can control. If we have control of what we're actually doing, then we can improve the CI/CD flow. And this is true also, that's an app case, so that's kind of a special case, but this is also true in Kubernetes clusters and whatever, because sometimes it takes 30 minutes to do the entire clustering thing, and that's unnecessary because we just have the front-end part. We can swap out just the client-side stuff, for instance. We have to have some sort of notion of what we're doing, and then we can apply that steps. So instead of just accepting the default workflow to try to make it conform into a Kubernetes type of thing that the platform engineering team has, we have to take control of our CI/CD flow as front-end engineer ourselves. And the simplest way to reduce cycle time, I argue, is to reduce the time spent for development. That's where you can reduce 5 hours from your CI/CD flow, but you'll still use 30 days from development time. So the easiest thing to reduce is development time. And I'm, of course, not talking about work harder or work faster, but work smaller. So to reduce the development time, you just have to reduce your scope you're trying to solve. So making small changes is key for being in a deployable state that can fix things and make us act quickly. I don't like being dogmatic, but ideally, and people on my team will probably say I sin on this all the time as well, but pull requests should ideally not be more than a day's work, probably. That's a rule of thumb that I break constantly. But the larger the changes are, the harder it is to avoid blocking, and the harder it is to coordinate across the team. No, I can't do that because I fixed things here. Yeah, when will that be fixed? Maybe in 14 days because we have to check this and this and this. So it causes everything to block, and it causes the code base to not be in a deployable state, which limits our notion to how to fix things quickly. So the simplest way is just to reduce the scope of each task we're doing. And I call it the simplest, but of course it isn't easy because it requires a lot from the team and it's hard work. So it's part technically it's a part technically issue, or it's hard technically to just solve it, but it's also cultural, and from a method standpoint, it's hard. It requires us to think about sizing of tasks. It requires us to be good to scope down, and it's always natural to okay, let's include that, or let's include that. But it's hard to say that's enough and move on. So it requires a team culture, and it requires a team to work on it together. And I think it's odd in some way that we developers are happy to talk about developer experience a lot, and developer experience as a enabler of DevOps mindset. But I think we should also talk about the board experience a lot more, and take responsibility as a team for the methods and processes we do, and use a board as a tool to achieve that. Because I think that continuous delivery takes hard work across the board. As a pun. So when you have small tasks and small changes, you will firstly avoid a lot of blockages, but also it's easier to circumvent the blockages that may occur. So it's a win all around, I think. But it's harder to do, but smaller changes will allow us to be more confident when rolling out fixes. One way to do this, from a technical standpoint, is to use feature toggling. It will allow us to roll out code in production that is void. This part of the code is just mute. It doesn't do anything. It's there, but it doesn't affect anything, so you can be confident that it doesn't break anything. It will never be triggered or executed, so it doesn't do any harm. We can also split changes to be more granular, like this will work for some of us. And this is often commonly referred to as feature toggling. So just remove a part of the production code you have, but it's still there, but it doesn't do any harm. Here's a good example to do that in front-end projects. Here's using something called Open Feature, which is a standardized SDK for a lot of different feature toggling systems, because even though feature toggling in its core is a simple thing, it's just toggle a feature. There's a lot of different implementation, a lot of different tooling for doing that. So, and they have their own APIs. Things like Open Feature uses that so you can be interoperable between the different implementations, like the Unleash or Flagship or whatever. And it also has support for something you have to think about when doing front-end development in modern era. Does this run on the server? Does this run on the client? A lot of typical feature toggling systems, like if you're using Firebase and remote config for feature flags, that requires you only to run in the client because it relies on Google Analytics and sniffing your email address under the hood, so you can't use it on the server side. But this makes it interoperable other implementations and easy to use. So from a consumer perspective, from this API, you just check, is this flag active? And according, if it's active, do some code. If it's not active, don't do it. So ideally, this shouldn't affect the production code. And when using feature flags like this, you can also use it to say, like, I want to roll out this feature for 10% of the base, and if it's by some reason breaking, we can roll back easily. You can also do this with just using environment variables. It's fair, but it's harder to do gradual rollouts. You require a deployment, which requires, again, is there any if we were not good enough to do deploys continuously. There might be like 5, 6, 7, 8 changes happening before we can do deploys. So requiring and changing a feature flag that triggers a build or something, and maybe something's changed. It's harder to like just do the triggering. So there is always trade-offs. Do you want to introduce a new SDK and a new API for doing it, or just use environment variables? And both are fine, but you will miss out on gradual rollouts and things like that. Even if we do continuous development and we master the craft of having small changes, we do small feature branches, we do feature toggling, and we are quick to respond, and we have a good culture for that. We still need to detect issues that occur. So we need to keep an eye if there is a rain. And believe me, from Western Norway, there will always be rain, so we have to be on the lookout. So what do we do when the first sign of bad weather? So first thing that happens, we have to backcast. So like, what's causing this issue? Why is something not working right now? And not every problem can be easily reproduced locally. I guess you have had these issues, especially in front-end development stuff. But trying to reproduce it locally, and it's impossible to do. And we have no mechanisms, if we're not done properly, to find what's causing this issue and track it to the specific line of code that's causing that. So this is the art of doing this is often called observability. And observability and good observability is the key of good debugging in production environments. So the better observability you have, the easier it is to act when something goes wrong. And again, it's easy to stand there and say that this is required. And if you ask someone, again, on my team, we have zero observability on our client system, essentially. We have some sort of thing, but so it's easy and it's important. And I would argue in front-end projects, which is essentially like distributed systems with agnostic software and hardware deploy sources or things, is even more important because you have no control over the environment. But yet, I argue that the people having least focus on doing observability right is also the one that has the most complex issue to solve it. So I think myself included need to be a lot better at this because it's hard to reproduce issues, and it's hard to find issues, and it's hard to do right, but it's worth the effort. So right now, I can think of 3 cases on the projects I'm working on that we are not able to reproduce the production issue, and we're just living with it. We're trying to improve logging, trying to improve things, but it's complex and reasons and whatever, but the fact remains, it's lacking observability at a good enough standard, and we're real people in Norway, buses driving, have a problem every day because of we have bad observability. So to be observable, we have to think carefully about tracing, logging, we think metrics, and so on. One example from an app perspective is breadcrumbs, where you can see what's causing an issue, here is an error, and you can backtrack what actions from the user has led to that action, that error. This is in SiteHub. You have the same in Sentry. You have the same in whatever, like error handling. New Relic is one, probably, whatever. You have a lot of examples that show you tracing or breadcrumbs over to what causes the issue. It's fairly quick to use, but still it's underutilized in a lot of ways. Open telemetry as well. For, again, even if you have like some sort of client-side solution and a server-side solution using an API there, it's hard to track where the issue occurs. So using open telemetry now is easier to trace across different platforms. Again, I say it's easier, but it's tough as shit. So it's hard to make right, and it's hard to understand, it's hard to use, but it requires us to actually try to improve it. Another thing I think is underutilized and I've used previously, which is nice because having to have some sort of relationship with how your system is running in production for end users is important. So we can use things like Core Web Vitals and just pipe them to whatever Prometheus or whatever data source for Grafana and make metrics and notices on when things goes wrong. For instance, how long does it take before the server even responds? How long does it take before you get the first image or the first content? How long does it before you can interact with said content? These are important metrics from user endpoint, and it should be important for us as well. And this is something that's hard to do because we're sitting there developing on 40,000 kroners laptops that responds very, very quickly, and suddenly we're running it in across different people that has less computer power, and it doesn't act the way we think it acts. And this is a really quick win to do. This is all it takes, essentially. You have to do some fail checking and whatever, but and you have to, of course, set up things like Prometheus and Grafana, but essentially it's easy to do. This is an example from Next.js. You could just have Next.js send all core vitals to your Prometheus data source, and it will track it all the time across all your different users, and you can utilize that to make metrics and do notifications and whatever. So it's a quick win, but I think a lot of people don't do it. So what's better than being able to act and detect issues fast? It's preventing them in the first place. So trying to detect as much as possible early and avoiding to have to do the reactionary causes as well. So this is often called a shift left approach, where we try to find a lot more things in the early parts of the development flow based. This will also contribute to closing the feedback loop faster. So the closer the feedback loop, the more issues you will prevent in a way. And what's often used for this is a testing pyramid. So we're starting with unit tests, the fundamentals of testing, and we do integration tests. We do end-to-end testing, which is the holy grail of testing, the all-powerful Illuminati top eye of testing. So it has the potential to catch a lot of relevant issues, bugs, and testing individual parts, more than testing the individual parts, because you're testing the entire system instead of just a single part. So you're testing the edges between the parts as well. And starting out with it feels really powerful, like testing if some title is set correctly and you run it, and it's run in 3 different browsers. It gives you a thumbs up. This works. It's set up correctly. Fantastic. But in real life, test looks more like this. There's a lot more async requests in the background. You have to wait from some particular state here. If that state is and it's very, very harder to do in real life. And you have to often rely on doing login and authentication in a way. And so you have the choice, should I try to make a specific environment for running end-to-end, but then you break the principles of having production near environments as well. And more often than not, this is what happens when running end-to-end tests. It works, and then it doesn't work, but it works, and it doesn't work, but you never know really when it works. So it's flaky in nature. So when pushing into your CI, you hopefully make it work, and if it works, it's only temporary, because it will break at some point. It's much more false negatives in the end-to-end tests that it needs to be. But luckily, because it's really, 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 really hard to make end-to-end tests work, I promised in the abstract I will finally show you how to do end-to-end tests. So instead of investing a lot more time, I think the solution is to focus not on end-to-end tests, but focus more on integration tests. So the solution to end-to-end tests and I will say, by the way, that this is only true for front-end projects that are complex, because Doing this, for instance, in the API, it's simple. Anyone can do it, even backend engineers. Unnecessary. But on front-end projects, there is a lot of different mechanisms at work that's not just an API, so it's a lot harder to do, both in the front end of things and in the back, because you have different dependencies back in the hierarchy of your system, and there's a lot of things going on in the front. So I like to think of, and coining the term, I think we should only focus on the testing burger instead. So focus on integration tests will give you much more bang for the buck in a case of being a trustworthy source to detect if something actually works or not. Because you can make end-to-end tests work in a front-end context for some time, but at some point you just lose faith that it actually catches any errors. And this will have the kind of the same semantics and kind of the same use cases, but it just drops the actual interaction with the design, and you spin up a virtual DOM representation and act on that instead. So I argue that it's kind of like testing an API itself. So even in end-to-end testing for APIs, you won't have some sort of robot trying to navigate your Swagger file and detecting the documentation. So there is a point at which you define this is end-to-end, and it all depends on where you're defining your end to be. I think that integration test is more stable. It's more, it gives you more confidence that you can catch actual issues. And it's a lot easier to do, and it's a lot easier to run as a part of your CI flow. Speaking of that, there are other ways of testing as well. We have an example. We were launching a new variant.no for a couple of months ago, and I think it was 4 days before launch or something. Just happened to see, like, is this loading slowly? And it's at some point we included the wrong package, which causing the bundle on the client side to be 12 megabytes large. So we included the entire Sanity Studio. So every time someone visits the site, it included 12 megs of JavaScript, which is unnecessary, to say the least. So this could be caught with of course, better processes as well, but shit happened. So this could also be automated by using things like Lighthouse CI, and that's what kind of like using the Web Vitals thing. It would just see what's the response time of this. Does this increase? Here I have an example running it locally, but you can also run this on a preview branch, for instance. And I argue that most front-end projects should have preview branches, even though it's hard to do in the Kubernetes setting. It gives so much value to verify your implementation to stakeholders or to yourself. So it's worth the effort to have preview branches, and then you can do things like Lighthouse checks on it. And that it has some sort of the same problems as end-to-end tests because it requires authentication and somewhat, but the results of running this are far less likely to do false negative tests. Other tests that is relevant as well is doing Pally tests or accessibility tests at a CI level. It won't catch all accessibility issues, of course, and it won't catch the accessibility issues you've introduced as a part of your the original concept or whatever. So, but it at least catches the dumb mistakes that we do, so we can use less time on fixing stupid issues and more on fixing actual user issues. So ultimately, I will say that DevOps is about ensuring production and that it works as expected. And to do that, we need to see that what happens in production, what's causing issues, how that backcasts to the code as well. We have to change some of how we code things. And I also argue that we have to have some sort of thought on the architecture of our front-end projects as well, because what we do in front-end projects, it affects how thing works in the deployment state and the operation states. Things like, should it use a CDN? Should we have some sort of front? Should we bundle like this? Should we configure bundles to be loaded by different places? And so architecture we're choosing also affects the operation parts of it and makes it easier or harder, depending on what we choose. But we also need to mitigate and verify in code and take responsibility of testing there. But first and foremost, DevOps culture is often like people plus processes, but we need to build some sort of a culture to take the responsibility and taking ownership. And that should be the fundamental reaction for every developer to take. This is not a problem that occurs and someone needs to fix it, but we have to fix it as a team. To do this, we need to avoid big launches, and we should be brave enough to do continuous deployment. And again, I think front-end developers also sin as much as the next one at this. And it's easy to just collect a feature after feature, and this isn't big enough to do release. We require a lot of manual testing, whatever. But more often than not, take down the scope, take down the issues, and increase the amount of deploys, and you will avoid having to do a lot of those tests. But it requires some sort of active mental state to do this. It isn't for most people, I think. It isn't like the gut reaction. So we have to build that gut reaction into the culture. So the combination of production and operational responsibility, the methodology, the philosophy, and the culture comes together, I think, as is on the DevOps part of thing. So think of that and it's definitely in your wheelhouse to do. For DevOps, for front-end engineers, we build a culture of responsibility. We tighten feedback loops, do quick minimal changes, optimize for flow. And again, don't be afraid to deploy, even though it's easy to be. Take control of tooling and understand why we automate, because I think it's important to not just automate because you think of that as good developer experience or whatever, but what's the intention of our automation here? Is it to discover some issues earlier? And the same goes for instance, linting. Why do we lint? What do we lint? Is it to avoid style issues, or is it to catch things that actually can break our production? This is within our control. And especially, I think, DevOps mindset is important for front-end engineer because we are developing distributed systems that is very hard and a lot more complex than I think we give it credit for. So I think that not only is front-end engineers that we should care about DevOps, but I think it is for front-end engineers, and DevOps should be a part of our core value. That's it. Old URL, nothing updated, but thanks for now.